Hello guys, you're welcome to Staad.Pro once again. In today's class, we'll be doing load combination. In our previous class, we did application of primary loads. As you can see here, we have self-weight applied already. We have slab dead load, which I've applied already. Wall load applied. We have roof dead load, roof load applied. We have roof life load. Then we have wind load in different directions. Yes, all this we have applied. So today we'll be doing a load combination with respect to Eurocode. Okay, so I will now take you to my Excel sheet where I did my combination. Okay, it's going to be in 4 categories as specified in Eurocode. We have load combination. The first one is serviceability limit state combination matrix for allowable stress. So we have SLS combination. We also have equilibrium combination for overturning, sliding, and uplift load. Yes, it helps us to check our uplift, overturning, and sliding. And after that, we do ultimate geotechnical load combination. This one is for foundation sizing. Yes. Then the fourth one is ultimate structural load combination, which is for member design. Good. So let's go back to Staad.Pro. For our load combination, we are already on load. You can see my cursor. Then you click on load combination load case. Yes, that's good. That's good. And here we give our combination name. So I used to name mine like this. See, SLS combination 101 is the pattern I normally use. So if you check the Excel sheet, 100, sorry, use 100 SLS 100 under serviceability limit state. All the dead load will be multiplied by a factor 1. There won't be life load and there won't be any wind load. So that will be my first load combination. So all the dead load multiplied by a factor 1. Yes, there won't be life load, there won't be any wind load. That's good. I'll copy this so that I don't have to type again. So I'll add this one is my load combination number 1. Then for the second one, I will 101. If I go to my Excel sheet, see the second one is all the dead load multiplied by a factor 1. Then the life load inclusive with the same factor. No wind load. Okay, go back here. All the dead load and life load with a factor 1. I'll add that. Then the third load combination, which is 102. Sorry. 102. The third one is this. So all the dead load and life load, then one of the wind load in positive direction. Then the next one will be the same thing, then plus the wind load in negative direction. The next one is the same thing. Then we'll just be alternating the wind loads. The reason being, wind load cannot act in 2 different directions at a time. So it must be in one direction at a time. That's why we cannot combine the two directions at the same in one load combination. So this is the ideal thing. Wind can only attack in one direction at a time. It cannot attack in 2 directions at a time. So the third one is with the positive x. So I'll have with a factor, one of them factor 1. Yeah, I'll have this from this to this with a factor 1. Add this one, Ctrl V, Ctrl V, 103. We have all these x in negative direction, factor 1, SLS 104, all these Z negative positive direction, then the last one 105, Ctrl V, 105, yes, then the negative Z. Add this. I'm done with the first load combination to 105. That's good. Then we go to equilibrium load combination. The first one is 200. Equilibrium load combination 200. Equilibrium, the short form is EQU combination 200. I'll copy it. Okay, so the first one is all the dead load we multiply by 0.9. Then we apply a wind load, dead and life load. Then we apply a wind load in x, positive x direction. So the reason for this is, remember, the aim for this load combination is to check our equilibrium and overturning moment and uplift. So this is, you want to reduce the dead load of the structure, by 0.9. Gets by 0.9. The actual dead load should be 1. When you multiply by 1, you get the actual dead load. But if you multiply by 0.9, you are reducing it by 10%. So you are reducing it by 10%, and we are using 1.5 to multiply the wind effect. So making the wind to have more strength. Yeah. So when this wind with this strength that we have increased attacks a structure, attacks our structure, what will be the reaction of our structure? So this will give us a reaction in the footing, maybe a moment that we can use to check our overturning, and the lateral forces that we can use to check our sliding forces. So that's just the idea for this equilibrium load combination. So we'll quickly do that. For the 200, we have 0.9 for all the dead load and life load. Then wind load is 1.5. We do it like that to these 2 or 3. Okay, we have all the including life load 0.9, 0.9, 0.9. Okay, then the wind load in x direction 1.5. We'll add 201, 0.9 or 2. Can copy and paste. Wind load in minus x direction 1.5. 202. Okay, need to copy again. Um, 202 equal to 0.9. Positive Z 1.5 and row 3, the last for this section, 0.9. The wind loading is minus Z 1.5. Okay, then we go back again for still on equilibrium, the same 0.9 factor. Then we now reduce the factor for wind load to 1.05. Okay, 1.05 equilibrium combination 204. The same factor 0.9. Positive X 1.05 and 25 0.9 negative X 1.05 206 minus X direction Okay, that's wrong. I've done this. It's positive Z 1.05 27 should be the last one. Yeah. Minus Z 1.05. Okay. The next one is ultimate geotechnical. Geo combination 300. So this one is ultimate geo. All the dead loads have a factor of 1, life load 1.3, and wind load 0.65. All the dead load factor of 1, life load 1.3, wind load 0.65. Yes, we are on course. Copy this, paste. 301. All dead load 1, life load 1.3, wind in minus X 0.65. Combination 302. All dead load 1, life load 1.3, 0.65. Combination 303. All dead load 1, life load 1.3. Okay, let me check 303. Okay, minus Z 0.65. And then the next one is the dead load. We have factor 1, life load 0.9, then wind load will be 1.3, starting from 304. 304. All the dead load factor 1, life load 0.9, 0.9, wind load 1.3, 1.3, yes, 305, 1, 0.9, 1.3, 306, 1, 0.9, 1.3, 307 be the last one. Yeah. 1, 0.9, 1.3. Okay. The last but not the least is the ultimate structural load combination. STR. Okay, so all the dead load we have a factor of 1.35, life load 1.5, then our wind load 0.7. We have STR combination 400, all dead load 1.35, 0.35, life load 1.5, wind load 0.75. Yeah. And 401, Okay, from 404 to 407, 1.35 for all the dead load, live load 1.05, then wind load 1.5, 404, 404, 1.35, 1.5, 1.05, 1.5. Zero 5, 1.5, 0.6, the last but not the least, 407, is 407, 1.35, 1.05, 1.5. Okay, then the remaining thing is to run analysis. We are done with load combination, so we'll just quickly run analysis. Click on analyze and design, then find the find command. Okay, under perform analysis, you can select all, add, close, then click on run analysis. Yes, I want to use this opportunity to beg you, if you are still yet to subscribe to my channel, please do so. Just do it this moment. Click the subscribe button and the bell button and give me a positive comment. Thank you. So our analysis have 0 error, 0 warning, and 2 notes. So let's go to post processing mode for us to see our analysis result. So from here, I will exclude all my primary loads and leave only my combinations here. So this displacement, if you bring out this table, it shows you node displacement, concrete building duplex, node displacement. Just click on the summary. You see the displacements in maximum displacement in you see 3.2 is the maximum displacement. In x direction, 1.5 So it's very okay, no issue here. If it is up to 25 mm, then we know we have issue there. 25 is not safe. Some persons use 50, but it is better to use 25 as the limit. So once you have a deflection of a displacement of 25 mm, then you should check your model and see if there's a way you can still brace it to reduce the displacement. So that's for displacement. Then here is for support reactions. If you click on this table, the summary, support reaction summary, you see the maximum reaction in x direction, the maximum in y direction. This is the maximum force at ultimate limit state that is coming down to the foundation at ultimate limit state is this. So you check the load combination is load combination 33. Let's see the one that gave us maximum. That's the load combination 401 gave us this combination 401. See 401. So this one gave us the maximum downward force at ultimate limit state. That's the meaning. So we have our maximum moment here. Okay, if you check this one is structural combination load case 405. It's giving us maximum moment. This one 10.889. Yeah. Okay, see this one. This one is giving us FZ lateral force. The maximum lateral force here is for equilibrium. Like I told you before, this equilibrium is for us to check uplift and sliding check, and it has to do with lateral forces. So you see it here now. Equilibrium combination 203. If you come here, equilibrium combination 203. See this one give us the maximum lateral force. With that lateral force, we can check our sliding, foundation sliding and overturning. Yeah. Yes, 10.66. That's for support reaction. So if you come here, this one is a beam results. So you see bending moment diagrams. Bending moment diagrams. See, as MZ is active. From here you can switch it to FZ if you want to display that one. FY is for shear force, FX, MX. So but what we normally use is, let me disable those ones. MZ and FZ, they are the shear forces and bending moment, the one we know. So for the MZ, if you click on summary, you can see the maximum moment. Yeah, maximum moment for the beams. So this one is on the column, the maximum moment on the column. So the software is going to use this moment here to design this column and provide reinforcement for it. You can even use it to design all the vertical force. Yeah, sorry, vertical, not moment, vertical force. So that's that. Okay, I think we will stop here. In our next class, we are going to be using RCDC to design all these concrete members. We do slab design with RCDC and provide reinforcement. We also do beam design, beam design with the same software and provide reinforcement. RCDC provides and produces drawings, detailed drawings. After slab design, it brings out detailed drawing, both top and bottom reinforcement. So what you need to do is just take it to AutoCAD and clean it up, and you are done with your drawing. So stay tuned, subscribe to my channel. I'm going to do this concrete design with RCDC, and you're going to appreciate how RCDC does concrete designs and does reinforcement detailing. Okay, see you next time. Thank you, and don't forget to subscribe.